Decades ago, child psychologists and educators largely agreed that teaching children more than one language was a serious mistake. The assumption was that exposing young minds to multiple vocabularies would confuse them and hold back their overall cognitive development. Modern neuroscience has completely dismantled that idea. Instead of causing confusion, learning a new language acts as a rigorous daily cardiovascular workout for the human mind. Juggling different words and grammar rules forces the brain to physically rewire itself. The continuous effort of managing multiple languages active at the exact same time builds new neural pathways and alters how the brain operates. To see exactly how these physical changes enhance our cognitive capacity, we have to trace the impact of bilingualism from childhood all the way through old age. A 2023 Great Ormond Street study categorized 8 to 10-year-olds into monolingual, early bilingual, and late bilingual groups. In an MRI scanner doing nothing, researchers measured their resting state. Scans showed early bilinguals had the strongest, most densely connected neural networks. It operates on the same principle as physical fitness. A trained athlete maintains larger muscle mass even when sitting perfectly still on a couch. A brain exposed to 2 languages from birth maintains denser connectivity even when it isn't actively solving a problem. This happens because learning a language as a young child effortlessly constructs completely new neural networks. Learning later in life requires older brains to push through the friction of modifying existing pathways. This early exposure establishes a higher baseline of physical connectivity in the brain, setting the structural foundation for advanced processing as the child grows up. As these children become adults, their brains manage a constant, invisible workload. Every time a bilingual adult speaks, their mind is actively working to suppress their other language, to prevent the vocabularies from mixing. This background suppression functions like a persistent cognitive filter. Managing that mental interference day after day directly sharpens an adult's concentration and improves their ability to navigate complex problem-solving tasks. This dual language environment also creates a split in how adults process information. Most bilinguals tend to react to their native language with intense emotion, since it's the language deeply tied to family and informal, intimate settings. The second language, however, is typically acquired later in structured, formal environments, like a university classroom or a corporate office. Because of this structured environment, the brain wires the second language differently. This model represents that split. Information processed in the second language moves through a highly rational, abstract, and emotionally detached neurological pathway. Every conversation requires a bilingual person to first identify which language their listener understands. This constant monitoring of another person's mental state acts as a social exercise, strengthening the brain's ability to step outside itself and grasp that other people hold different points of view. The result is an adult brain equipped with a unique dual processing system, balancing rigorous logical detachment with deep psychological empathy. Acquiring a new language as an adult is biologically difficult. Instead of building fresh pathways, the adult brain must forcibly twist, modify, and cram new connections into an already established neural web. This severe biological friction is actually the point. The immense struggle required to learn a language later in life produces some of the strongest neuroprotective benefits of any mental exercise. In 2007, researcher Ellen Bialystock and her team in Toronto published a study that forced the medical community to look at language in a completely different way. This timeline charts the onset of cognitive decline based on her findings. The data showed that bilingual patients developed dementia 4 to 4.5 years later than those who only spoke a single language. The researchers also tracked patients recovering from severe neurological events, finding that bilingual brains regain their functional abilities at a significantly higher rate following a stroke. The daily mental strain of juggling 2 languages acts as a literal shield for the brain, capable of delaying the onset of degenerative diseases by almost half a decade. This defensive capability is cognitive reserve. Think of it as a neurological savings account built through complex mental tasks, acting as a buffer against aging and disease. Language uniquely fills this reserve because it's incredibly complex, simultaneously demanding auditory perception, abstract thought, and physical coordination. This shift in biology translates into a shift in social reality. A second language provides the literal tools to navigate different communities, allowing a person to inhabit new cultural frameworks and internalize ways of seeing the world that don't exist in their native tongue. Learning a second language modifies a person's very perception of reality, layering new sounds, concepts, and emotional nuances over their existing experience. Becoming bilingual requires intense effort, but it pays off as an incredible lifelong investment, expanding both the physical durability of the brain and the emotional depth of the human experience.